1988. After 2 years of work, Challenger opens its doors. 20 years later, a renovation project of the occupied site was initiated, intended to make Bouygues Construction's headquarters a showcase for its expertise in sustainable renovation and a full-scale experimental laboratory. Various options were studied to improve the insulation of the buildings, reduce their energy consumption, and to make rational use of the local energy resources: water, earth, air, and the sunlight. Long-term performance capabilities were analyzed, including incorporating operation and maintenance issues, staff comfort, and disabled access. The result, Challenger, is one of the very first tertiary buildings to be renovated to produce, within conventional scope, more energy in a year than it consumes. Mains water consumption is reduced by half, falling from 59,000 to 28,000 cubic meters. Challenger holds triple certification: HQE Very Efficient, LEED Platinum, and BREEAM Outstanding. Particular care was given to dealing with waste from the renovation, with more than 80% of materials recycled overall, including the complete recycling of the entire 45,000 square meters of carpet. The renovation of the buildings was performed with the site in occupied use in phases of 10,000 square meters lasting 6 months each, including moving teams out and moving them back in again. Challenger has 25,000 square meters of photovoltaic solar panels, generating a peak output of 2.6 megawatts. Photovoltaic panels are a set of cells made of light-sensitive materials that, when hit by rays of sunlight, release their electrons and so produce an electric current. All panels are fitted with a system to isolate their individual operation, offering 3 advantages: an improvement in safety by allowing electricity production to be cut, notably using a manual fire brigade cutoff; simplification of the process of locating a faulty panel; optimization of energy production. In fact, on a standard photovoltaic system, when a panel is in the shade or develops a fault, the entire system is affected. Thanks to its optimizer, however, when a panel is producing less in this system, the others continue to produce at optimal levels. The energy produced is used on site, with only surpluses sold back to the electricity company. A solution for storing photovoltaic energy using reconditioned batteries from electric vehicles is also being tested by the R&D teams. 180 dual-sun hybrid panels complete the installation. These panels supply both photovoltaic electricity and hot water. This solution improves efficiency by using the heat in the panels and making the installation safe by avoiding risks from overheating. Hybrid panels are also used for nighttime cooling of Challenger's thermal loop. In order to regulate the temperature, Challenger has a geothermal installation that uses heat naturally present in the ground. The installation consists of 75 vertical boreholes and a geothermal doublet on the groundwater table. Fluids plunge 100 meters down into the vertical boreholes to exchange calories with the ground, 12 degrees Celsius, while the geothermal doublet extracts calories from groundwater drawn at a depth of 135 meters, 14 to 15 degrees Celsius, and then re-injects it into a second borehole at a depth of 152 meters. In order to heat buildings, the calories harnessed by these 2 geothermal systems are then conveyed to heat pumps designed to enhance the calories. For 1 kilowatt-hour of useful electricity for operating a heat pump, the latter produces between 4 and 7.9 kilowatt-hours of heating, depending on the model. 4 plate heat exchangers were installed. They use the underground coolness to chill Challenger's thermal loop by exchanging calories between the 2 environments. In this configuration, the ground could also be used as calorie storage during the summer to increase the heat system efficiency for the following winter. Supplied with water from filter gardens, 5 Abadiatic coolers complete the cooling system. The advantages of these condensation air conditioning installations is that they are light on energy consumption and, above all, unlike conventional towers, they do not disperse drops of water in the air, thus avoiding any risk of Legionnaire's disease. With a volume of 250 cubic meters, the thermal loop installed when Challenger was built transports heated or cooled water through all the buildings and feeds the VRF, or Variable Refrigerant Flow air conditioning units, installed in technical rooms on each floor. These systems, which work like heat pumps, are able to heat and air condition areas individually. The system's major innovation, developed with LG, lies in the installation of a water flow control valve that substantially reduces electricity consumption by the pumps circulating water around the loop. As well as installing equipment to produce green energy, Challenger's thermal efficiency was also reviewed in detail. With this in mind, the insulation of walls and terraces in contact with the outside was enhanced, and 88% of Challenger's glass facade has been replaced by a naturally ventilated double-skin wall. This new facade features several advantages. In summer, to begin with, the sun heats the air inside the two walls, which, under the effect of heat, is naturally evacuated via the top of the facade. In winter, the cold is first of all captured by the air circulating in the facade, thereby limiting the impact of the outside temperature on the buildings. Fitted between the two walls, automatic blinds play an essential role in improving thermal efficiency of the facade and allow members of staff to control glare using a command on their PCs, thus involving them directly in the initiative. Renovating Challenger was also an opportunity to create a new working environment for staff, more pleasant and better suited to contemporary mobility. The interiors are decorated in light tones to provide the best natural lighting in the open-plan office spaces. To enhance visual comfort, each desk is fitted with an individual LED lamp whose brightness can be adjusted. Air quality is optimized. The metal false ceiling and acoustic insulation panels covering the wall cupboards in particular improve acoustic comfort. Over 100 mini-meeting rooms, accessible without booking, have been created in the open-plan offices, and the number of full-size meeting rooms increased by 50%. Signage has been completely redesigned, and 2 new car parks with 400 spaces have been created, fitted with cloakrooms for employees traveling by bicycle. 250 parking spaces have been earmarked to be fitted with the equipment necessary for recharging electric cars. To optimize the use of this array of equipment, a control center called the cockpit has been built. Just like a real flight control tower, all information will be monitored in the facility. Renovating Challenger also addressed the question of how to manage site rainwater and wastewater using a natural sanitation system known as filter gardens. They operate independently without discharge into the public network and in a completely natural way. Made up of artificial wetlands, the filter gardens are planted with a wide range of vegetation such as reeds, rushes and irises, which create favorable conditions around their roots in which microorganisms can thrive and which feed on impurities in the water. Wastewater passes first through a vertical filter that traps matter in suspension and constitutes the first stage in treating nitrogenous compounds. The water continues on its way towards the horizontal filter, where nitrogenous material decomposes completely. In addition, for their growth, plants consume the remaining organic molecules and phosphorus. Finally, wastewater reaches a storage lake where the sun's UV rays destroy the remaining germs. It's then used on the site to water green spaces. Where rainwater is concerned, this is collected on the rooftops, roads, solar farm and gravel areas, and then follows a specific purification process. It goes through a trapping filter with 3 major functions: getting rid of suspended material in rainwater, biodegrading remaining hydrocarbons, trapping metals. The water is then stored in 2 landscaped lakes with a total capacity of 1,110 cubic meters before being reused to supply adiabatic coolers, toilets and car wash facilities. Recycling wastewater and rainwater enables Challenger's water consumption to be reduced by almost 60%, a saving of around 60,000 cubic meters of water a year. Filter gardens also constitute a wetland environment which promotes the development of local biodiversity and have contributed to the Jardin de Noé accreditation of the site. Triple certified at the highest level, HQE, LEED and BREEAM, Challenger is a showcase for the group's expertise in sustainable renovation and a full-scale experimental laboratory for Bouygues Construction's R&D teams.